Recording in progress.
Dr. Ashok will not be able to join us, so we will start with the presentation. So, good afternoon to all of you. On behalf of Computer Science Department, NIT Raipur, and 4th International Conference on Machine Learning and Emerging Intelligence and Signal Processing, I welcome all respected session chairs and participants. Before we start the session, let me introduce our esteemed session chairs. Our first session chair is Dr. Our first session chair is Dr. Nitinda Ojha. He is an associate professor in the Department of Computer Science and Engineering. He has earned his PhD degree from Indian Institute of Technology, Allahabad, and he has published more than 30 research papers in various international journals, national journals, international conferences, and book chapters. His research interest includes deep learning, machine learning, natural language processing, multi-objective optimizations, etc. Our next session is Dr. Nagrani, Naresh Kumar Nagrani, sir. Dr. Naresh Kumar Nagrani, sir, is an associate professor at the National Institute of Technology, Raipur. He has more than 50 research papers and more than 10 book chapters to his belt. He is on having industrial experience of more than 3 years with Persistent System Limited, where he was a part of the software development team and developed data scientist analytic software such as SPSS and transaction process system. His research interests in data mining, graphic mining, fuzzy logic, text mining, etc. Thank you, sir, for joining the session. I may request all the session chairs and participants to on their video. This session we will have the 5 papers to be presented. The first paper ID is 7, who is going to present. I may request the session chair to start the session.
Yes, Arti, you may start the session.
Yes. Paper ID 7?
Yes, yes, I'll be sharing in a minute. Oh. So, is it, wait a minute. Is it visible?
Yes, yes.
Okay. So, good afternoon to everyone present over here. I, Riyang Ghosh, from DST Center of Interdisciplinary Mathematical Sciences, Institute of Science, Banaras Hindu University, will be presenting our paper, Dual Classifier-Based Fake News Analysis using Supervised Machine Learning Approach. The following is the flow of my presentation. I'll start with a brief background, followed by literature survey, problem description, methodology, results and discussions, ending with some concluding remarks. Background. This paper is centered around the broad concept of text mining. Text mining, also referred to as text analytics, is an artificial intelligence AI technology that uses natural language processing NLP to transform the free, unstructured text in documents and databases to normalized, structured data suitable for analysis or to drive machine learning ML algorithms. The paper focuses on the latter application, that is, driving ML algorithms. We have used text mining techniques to train a ML pipeline, which consists of two classifiers, classifier 1 joined to classifier 2, that will help us segregate real news from the fake and further classify the real news across some predefined classes. Of all the literature that we went through, here are some of the important ones ordered in the order of the classifiers. For classifier 1, the ones from Shlok Gilda were important, who proposed machine learning algorithms for fake news discovery. They explored papers and compared the performance of models using three distinct point sets to understand what factors are most prophetic of fake news. The ones from Chandramouli Madhav Kotetti et al. And Arjun Rao Kengshuk developed deep learning models for detecting fake news, which were grounded on convolutional neural network CNN and bidirectional long short-term memory by LSTM networks. The ones important for classifier 2 are the ones from Kaur et al., who presented a system for the classification of news articles based on artificial neural networks, and the ones from Liparas, Kerner et al., who used n-gram textual and visual features for classification of news articles that fall into four categories: business finance, lifestyle and leisure, science and technology, and
Yeah,
sports.
that's it.
Problem description. Since the advent of the internet, whatever was available to us physically has created a copy of itself in the digital matrix. The news sources suffered no differently, but as they say, that internet belongs to no one. Hence, it is as easy for a phony to produce news as it is for a news house. This poses the crisis of credibility. The purpose of this research was to present an industry scalable and readily implementable solution to address the above issue. Methodology. The flowchart describes the process flow we adopted into creating the two classifiers. It starts with acquiring the input data sets for training the classifiers. As the text data can't be crunched right away, the data sets have to be put through a processing step where we'll first analyze the balance among the classes of the data sets. It will then be put through cleaning to get rid of non-predictive strings. The resulting corpus is then split into training and testing sets. Training sets are then sent for for feature generation. The features are then used to train their respective candidate classifiers. The classifiers are then tested using the test dataset. The best performing ones are then chosen as the optimal classifiers for classifier 1 and 2. After training both the classifiers, we have to tweak the system to meet practical scenarios, as more often than we realize, news clips will belong to multiple classes at the same time. Hence, the trained feature classes of classifier 2 will be used to associate a vector of conditional probabilities. Thus, the articles along with the appended conditional probability vectors are stored in the repository as shown in the figure alongside. Here is the methodology for hanging conditional probability vector. Let A be an article which has a feature set of small f. Let capital I running from 1 to 5, be the feature set corresponding to each level: business, entertainment, sports, tech, and politics, respectively. Let capital I running from 1 to 5, be the event that the article A belongs to one of the classes: business, entertainment, sports, tech, or politics, respectively. Then the conditional probability that the article A belongs to a class is probability EI given A is equal to the order of the intersection of F and Fi over the order of F. Indexing the articles. Let probability of AI given A and probability of BI given B be the conditional probability scores for articles A and B under a certain class label. If probability AI given A is greater than probability of BI given B, then article A will be indexed before article.
Mriyank, I would like to pause you over here. Aarti, how much time do we have per paper? I think there are 10 papers in this session, right?
Sir, 10 minutes for presentation and 2 minutes for question answer.
Yes, 10
Okay,
minutes.
so I think all the presenter must take care of this time limitation. Okay.
Okay, so I'll just wrap up. The article A hence will be indexed before article B under this class label. Following are the results that we acquired after our experimentation. The classifier 1 was tested across these candidate models. We found out decision tree classifier to be the best one according to the test set accuracy it described. Alongside the test set accuracy table, we have the confusion matrix for decision tree classifier. In classifier 2, we tested it across these following candidate models. We found out support vector machine to be the best one according to the test set accuracy. Though the test set accuracy of 94 was shown by two models, but we chose support vector machine because its training set accuracy assured us of no overfitting. Adjoining this, we have the confusion matrix for support vector machine. Here is an example of the conditional probability vectors assigned to an article. Here I have assigned conditional probability vectors to 3 example articles and then index the articles under the business class label. The articles have been indexed in the decreasing order of the conditional probabilities. Conclusion. For classifier 1, among the 5 models, our best model, that is the model with highest accuracy, is decision tree classifier. The accuracy of this model is 94.86%. For classifier 2, support vector machines were pretty effective classifiers given their performance in the training and testing dataset. As far as further developments are concerned, the present design of the dual classifier is good, but could be improved if classifier 2 was turned to a fuzzy classifier. The individual classifiers can be improved by applying probabilistic techniques. Moreover, based on this design, it can be used for any two-phase text classification procedure, externalizer as well. Here are the references that we went through during the course of this project. Thanks a lot. I am open for questions.
Mriyank,
Yes.
what was your data set?
So the dataset, we used 2 datasets. One was a fake news dataset that we got from Kaggle, and the other was a dataset that comprised of 5 category news articles that was from UCI.
How large was the data set?
Both of them were something around 2000 to 3000.
Okay, the methodologies that you have shown the results of, what is the significance of probability vector over there? Because I don't see that any of the algorithms use probability vector.
Oh,
Go back to the result, the last
yes,
result.
yes. So the probability vector is used for indexing the articles when we store them in a repository. Suppose the user wants to access an article, so the probability vectors will index the articles in the order of the most relevant one.
Okay, so it may be a data warehousing problem, right?
Yes.
It has
Yes, we
nothing to do with the
extended this.
classification.
No, classification
What was
thing
your
ends
title?
over here.
What is the title of your paper?
The paper was dual classifier based fake news analysis.
Okay, dual classifier. What are the 2 classifiers you have used?
The first one was the decision tree, which was for fake news and real
And
news
the second one is
classification,
support vector, right?
and second one was support vector machine.
You have go to your result page. Okay, I concentrate my question to the classifier part only. When you see decision tree, I find it very hard to accept this logic that decision trees are giving better result than random forest. Okay, because decision trees are prone to overfitting, and that is why random forest, because they introduce the criteria of the voting and avoid overfitting. So random forest always in I would say 99% of cases give better result than the decision tree classifier. And other than that, I should actually in your training set accuracy, I see that there are a lot of 99%. Okay, but testing accuracy is 94, 94, 93, 92, and 93. All of these suggest that there is an overfitting. So is there a validation that you have performed on the data set also, or it is just training and testing?
No, yes, the hyperparameter setting, we did a k-cross validation process.
So, can you show the result of your validation also? Have you reported that in the paper?
I don't think I have reported because it was an intermediary step. We
No,
don't.
see, validation is very important because at that point of time, you understand whether your model is overfitting or not. And this result clearly shows that model is overfitting. And further, in this era, I think all the algorithms that you have taken, logistic regression, decision tree, random forest support vector machines, or gradient boosting, all of these have already been tested 15, 20 years ago. Now is the time of deep learning. Did you not think of trying deep learning or neural network based classifiers? Because it's just natural language processing, and we are doing a lot of good work through deep learning models.
Our actual was to bring a end-to-end kind of a system where the fake news comes from one side, which is a very raw fake news, and then the user on the other end gets a classified
That is just
label. Yes.
just programming part. It comes from one interface and goes to another interface.
Yes.
I'm talking about the algorithmic part, the
Okay.
classification part. And even in your future work, you are suggesting that fuzzy logic may produce better result, but I don't agree to your future prediction, because fuzzy logic has already been shown to be working good or bad, or relatively average results are being produced. And these the paper that you are presenting, this would have been a good paper 20 years back. Okay, now is the time of deep learning. We are producing almost 99%, 98% fake news detection through deep learning methods. There is no use of feature generation. There is no use of these kind of work that you are presenting. It's 20 years old work. Fuzzy logic has already been worked and tested. Nothing new in the paper. And you must try with deep learning methods. And I think deep learning will be a better option for you to explore for these kind of tasks. Okay.
Thanks a lot. So actually, we are still master students, so deep learning is a bit advanced for us.
We are teaching deep learning to BTech students. So you are already past that stage when you should know the deep learning. Okay.
Okay, so we'll surely try it.
We can move to next presenter.
Sure. Am I audible?
Yes, yes.
Okay. Is it visible to you?
Yes.
Okay. Actually. Hello, very good afternoon, everyone. My paper title is Approach of Different Classification Algorithm to Compare in Income Feature between Bangla Good and Bad Text Discourse. Now, I am the presenter MD Hassan Bijoy from the Department of Computer Science and Engineering, Daffodil International University, Dhaka, Bangladesh. In this paper, I have four co-author. They are also from Jafrul International University, Dhaka, Bangladesh. Now to come to the presentation outline, I will talk about the background of this study, some objective and motives, literature review, methodology of this study, result and discussion, and finally conclude the presentations. Now in the background, we live in a digital age when everything can be accomplished with the help of smart technology. The amount of time we spend interacting with computers is steadily increasing. Bangla natural language processing is a newish challenge in artificial intelligence. With the rapid expansion of the Bangla language, it is now adopted on a variety of platforms, including social media, communications platform, news media, and so on. So the classification of text document becomes an important factor in resolving the challenge of information organization and knowledge management. So these studies use the 5 supervised classification methods to explore the categories of Bangla text discussed using Elgam technique. Now the literature survey. So Tahir and all of the author try to address the sentimental analysis problem, largely utilizing the support vector machine for classification and the Ngram technique for vectorizations. And Bijoy and all of the author propose an automated term by applying many machine learning techniques to categorize the sentence. They use 740 text documents and to apply their classification algorithm, and they have applied KNN random forest decision and the extend gradient boosting classification algorithm. And further, and all of and the alum presented a methodology for the analyzing sentiments in Bangla comments text. They have applied conventional neural network architecture to build a model that can distinguish between positive and negative sentiment with a 99.87% accuracy. Now the objective and motivation of this paper, we want to build up a model that can recognize the Bangla good and bad text discourse by machine. And then we want to classify the good and bad Bangla discourse from human context. We want to build up a model that can provide the advantage of human interaction with computer using Bangla language. So to select the best classification algorithm for classifying Bangla text with the largest amount of model error and highest accuracy to fit our data set. To do some research on natural language processing and develop a model that helps the Bangladeshi people to interact computer in their own language. Now, in our methodology, first of all, we collect our data from various social media, people conversation, and the Bengali banks, and we are capable to collect 1,459 Bangla data. Then after the collection data, we apply the data preprocessing first week, primary cleaning, text split and add construction, remove the regular expression, remove Bangla stop words, and purified text. So in our data preprocessing primary cleaning, we manually check the data is all organized or not, then checking the message spelled and remove the small text less than and 3 words. Then we apply the split the text, add construction like doctor, dots mean doctor, and engineer to engineer. Then we remove the regular expression like punctuation, special character, numeric value, etc. Then we remove the Bangla stop words like that and slot text. Then we got the purified text. After preprocessing, we need to encoding the text, and we applied the counter vector to tokenize the data, and we updating their class as 0, 1. Yeah, in our model fitting, we applied the Ngram technique to apply the classification algorithm, logistic regression decision tree classifier, random forest, multinomial neighbors, and KNN. And after from the model fitting, we compute the testing results as a accuracy score, generate the confusion metrics, also precision and recall F1 score, and select the best model based on their performance. So in our data classification, we split the data 80 to 20 to 80% data used for training purpose and 20% data we used for testing the performance of classification algorithm. In a confusion matrix, we see multinomial naive provide the maximum correct value with the 259 value, and logistic regression provide the maximum wrong value with 87. So in our classification reports, we see multinomial naive Bayes perform the best as in our unigram trial. Then in our bigram trial, also multinomial naive Bayes perform the best, and in our trigram trial, we see KNN perform among the 5 classification algorithm. So to compute the best accuracy from our applied algorithm, we see as a multinomial naive Bayes provide the best accuracy with 89.81 accuracy in unigram trial. Then in bigram trial, multinomial naive Bayes provide 89.67 accuracy. Then in our trigram analysis, we see KNN provide 85.44% accuracy. So now in our conclusion, so we know in artificial intelligence, natural language is relatively new challenge. So Bangla is presently used a range of platform, including social media communications platform, news audience expansion. We use a different classification algorithm with the income features for classified output. So multinomial naive Bayes provide the classified.
Please mute if somebody is not part of the presentation. Please mute yourself.
The accuracy criteria. In picture, we can apply more deep learning classification,
Raghav sir?
neutral position of data.
Aarti, please mute the
There is
Yes, sir. Yes, sir.
mute the
background.
background.
So here are some references that we have used in our paper. That's the end of my presentation. Thank you all. Now I'm taking question from you. If you have any query or question, please feel free to ask me. I will try to answer.
Mr. Hassan, what is good Bangla and bad Bangla? I didn't get the difference.
Actually, good Bangla and bad Bangla is like kind of free speech and offensive is like that. Free speech is a good language, good Bangla, and offensive language like that. As example, I had the person like that is the bad Bangla language. It's kind of
Free
slang
speech
or
versus offensive.
yes, like that.
So if I hate a person, that is a free speech also, and I am free to say that I hate the person. It might be offensive to somebody, but it is free speech. And if somebody is speaking freely, it is definitely offensive to someone else. Someone might not like it. Probably like take an example of a politician. I might like I might like a politician. I might not like a politician. So I am free to criticize somebody, but that is
Yeah,
free.
definitely you can.
Then how do you differentiate with a machine learning model? How do you differentiate?
Actually, we collect the data from social media, which we know there is a many person to comment on their use the slang language to attack someone. So we
Okay, so what is the ground truth here?
sorry.
Ground truth in classification task. Classification is a supervised learning algorithm. You need ground truth also. How do you label the data to be good Bangla or bad Bangla?
Actually, we collect the data manually. So when we collect the data, we set the value as is a good or is a bad. Then we train the model.
Okay, it means whatever you like to be good is good, and whatever you decide to be bad is bad, right?
Yeah, one kind of, yes.
And how big is your data?
It's more than 1500 Bangla text document.
And you have collected it as a tweet, Bangla tweet, right?
Not like the I'm collect data from social media, comments,
No. I mean,
blog,
the
and people.
comments language of the comment is in Bangla or English?
It's a Bangla, bro.
Bangla only.
Yes.
And can you, what are the features that you have created over here, or it is just unigram, bigram, trigram?
It is over just only unigram, bigram, and trigram.
But in trigram, I doubt whether you are able to express the sentiment or even. Can you give an example of what are the trigrams? Because I sincerely doubt a lot of tweets that we see. If I try to create a trigram, unigram and bigram are totally useless, because unigram, I might say that I hate. Okay, like
Yeah,
hate, unigram is hate, single word. You are using single word.
yeah, unigram combine the probability of single word. Then
So there is no use of unigram because hate might be there, but
yeah,
hate is like I hate the people who use slang for women. Okay, or
yes,
I can say I hate the people who are offensive to women. So my statement is very genuine because I hate the people who are bad. But
yeah.
with hate and bad and offensive, if you use these three words individually and you don't look at the context, then you would classify my tweet to be a bad tweet. However, it was a very good tweet that I hate the people
Yes,
who are offensive to women. So
okay, got
unigram
it.
is useless. And
Useless. Yes.
bigram also, I don't see. I try to get a context out of it. If I use two words only, I hate people. So hate, I hate or hate people. This is the only two bigram you can get out of it, right?
Yeah,
So
but
offensive to women. So two women offensive to. Again, you get that my tweet is a very bad tweet. However, it was a very good tweet. So
like,
unigram and bigram are useless in your data.
but
Useless,
yeah,
useless
we
with
remove
trigram.
whole sentence. We remove, we use more than 4 or 5 word in a sentence.
If you use more than 4 and 5 words, that is no longer unigram, a trigram. That becomes quadragram or pentagram.
Yeah, like that. This is actually fast work. That's why we try to learn something from this.
Okay.
Hasan, just two questions from my side. One is like you have tried to cover the comparative study of various classifiers. So we can see multinomial, nav-based, random forest, KNN. So if you might have covered the SVM algorithm also, then I think that the bucket of traditional machine learning algorithm can be complete. So do you have any reason that you have not included a few more algorithms on your comparative study like SVM?
No, actually, I want to. I have applied more than 5 algorithm, but those are 5 algorithm shows the best accuracy. That's why I shows those 5 algorithm in my paper. I have also
Okay.
applied, but they did not give the satisfied results.
Yeah, okay. And one more observation from my side is what sir has pointed out, that when you are going from 1 gram to 2 gram to 3 gram, you can notice that you are getting drop in the performance actually. Accuracy values are also getting decreased actually.
Yeah.
So probably whatever data set you have, when you are trying to get 2 gram or 3 gram, then it is breaking the semantics of label in the supervised machine learning data set, something like that. So you
Yes.
need to explore that, whether only unique individual term is sufficient for your analysis, or
Yes.
you really wanted to go for combining the terms and you are going for bigram, trigram kind of thing.
Yeah. Okay. Thank you, sir.
Yeah.
Sir.
Thank you. That's it.
And in our next work, we will apply deep learning like algorithm. So
Yeah.
with more data. Thank you, sir. Thank you.
Now I would like to invite Margi Patel for paper number 111.
Yeah, thank you so much, ma'am. Ma'am, am I audible?
Yes, yes. You can share your
Yeah,
screen.
thank you so much. Yeah. Okay, so good afternoon to honorable session chairs, to organizing committees, and all my colleagues who are present right now here. So I'm here to present, give a presentation on the work, which is a part of my research work. Gujagara, an acyclic graph to unify semantic knowledge, antonyms, and Gujarati to English translations of the input text. This is the layout through which my presentation is going to go. Okay, so what we have seen in today's era is that data and information visualization is becoming strategic for the exploration and explanation of large scale of data from human perspective. Thus, visualization is a closer phase to the users within the data lifecycle phase, and thus an effective and efficient way of representation of data is required. So in this research work, we have come up with a solution of displaying relationships like synonyms, antonyms, and Gujarati to English translation of the text which we are giving to the system, which I am going to present here. What we have seen in today's era is that most challenging task in natural language processing is recognizing the correct sense of each word that appears in the input expressions. Word in natural languages may have many meanings, but depending on the context, it's very important to identify right sense whenever that word is being used. WordNet is widely regarded as a vital resource for scholars working in computational linguistics, text analysis, and a variety of other fields like machine translations. Several WordNet compilations initiatives have been undertaken and carried out in recent years under the common framework of lexical representations. And they are becoming more and more essential resource for natural language processing applications such as machine translation systems. The effort of determining the right sense of word in a particular situation is known as word sense disambiguation. Many natural processing applications, particularly information extraction and machine translations, need word sense disambiguity as an intermediary step. Now, for example, let us take an example of a word mouse. It has several meanings, like in first sense, it means a computer mouse, which is used to move the cursor from computers, which fits in electronics category, but one mouse fits in animal category. This distinction is obvious to the people, but for computer to perceive it, it must have knowledge base or it should be educated. To accomplish words as disambiguations, there are many ways that has been presented, like knowledge-based techniques, supervised approaches, or unsupervised approaches. These are the main approaches that have been identified to accomplish the task of word sense disambiguation. As I've already discussed, that data and information visualization is becoming strategic explanation of large data set due to its great impact on the point of humans perspective. For a wide range of natural language processing applications, from digital dictionaries to the automated machine translations, WordNet perhaps seems to be the lexical resource that may be applied. There are many WordNet created on all Indian languages. Still, there are a lot of syntactical and semantical relations required for these languages. Here, in this work, we have chosen one among many languages, that is Gujarati WordNet semantic relationships, and shown them as an acyclic graph. Also tried to illustrate the process of creating links between Gujarati